Well, hi and welcome. Thanks for coming and joining me in my shop here for what I think is going to be, what I hope anyway, is going to be a pretty interesting session. So since the video yesterday, I've learned a few more things about this radio. The first one is the cord I thought was missing is not missing. I was simply completely mistaken. This is the cord wired right into the amplifier here. And this plug, which I mistakenly thought was a connector like this is just going to the speaker, and the speaker's plug is hanging on the speaker behind me here. So that confusion's over, but that means there's nothing stopping me from operating this. Number two, the owner, who of course is watching these videos, has told me that this radio was serviced about 20 years ago, I think he said. And so that's what I'm seeing in here when I see these parts that are in there. He said it was serviced in a professional shop, storefront shop, I believe. So I'm a little surprised at the variation in the capacitors that have been installed. I mean, as you know, if you look at what I do, it's the same kind of capacitor coming out because I buy them in bulk. Who wouldn't, doing this kind of thing? So to see all different types of capacitors really screams out junk box repair. And this shop may have been chopping out parts from old radios they were scrapping and then using those parts again. So there's a good chance of that. 20 years ago, a fellow, let's say an older gentleman running a shop like that, 20 years ago, excuse me, what, 20 years ago, that's 1999, may not have availed himself of all the advantages on the internet, and a lot of those advantages may not have been there yet. So for instance, Radio Museum and other like Pacific Radio and TV, they may not have built up their internet collections of information about radios. So when you look back 20, certainly 30 years, it's a totally different environment where parts are a little hard to get, and most importantly, information almost impossible to get for these things. So today, it's as easy as can be. In fact, information's pouring over us all day these days, of all sorts, including stuff we don't even want to hear about. So also, so these tubes, let me pull one out here again. I think I put this in front of that. Wow, these are really gripped in there. Holy smokes. So 2A3 made in China. So the owner has told me, as far as he knows, these tubes were installed when the set was reconditioned 20 years ago. So these are 20-year-old tubes. China. So whatever shop it was that was doing this, they somehow were acquiring tubes from China. That's kind of interesting in itself. So there's really not much reason to think these are defective or any of that. And how many of these tubes appear, we haven't really looked at them, also got changed, I don't know. I mean, certain tubes have been remanufactured lately. Those are tubes that are in demand. Those are mostly output tubes intended for guitar amps and maybe some high-end stereo tube equipment and stuff like that. The 2A3 is a tube which would fall into that category. Coincidentally, it's also a tube you find in a 1930-something radio. Now that can't be true about all of them. So for instance, this is a 5Z3. It says Sylvania, made in USA. I'm sure this is a vintage tube. I don't think there's anything new about this. What did it say? Yeah. 5Z3. Now, you know what? Before we plug this in, come to think of it, I want to look a little closer at the rectifier tube, because the tube that's in here is a 5U4 as opposed to a 5Y3. It's calling for a 5Y3, and I'm holding a 5Z3. Oh my gosh, that was too much. I confused myself with that. How similar are these tubes? I don't think they're direct substitutes. So there's the 5U4. So there's his socket here. Pretty impossible to tell looking at it if it's been rewired to accommodate a 5U4. Let's just take a look in here real quick. 5Y3, 5U4. I just don't think you can pop one in place of the other. 5Y3. Oh, it's a 5Y4, and right after it is a 5Z3. Oh, that's just alphabetical change. It doesn't mean anything. There we go. 5Y3. discontinued type. So for discussion of rating chart and operation characteristics, refer to type 6A5, no, 6AX5. I didn't say, okay, 5U4. Let's look at the pinout here. So 5Y3, see the heaters are 2 and 8 and 4 and 6 on the plate. 2 and 8, 4 and 6. 2 and 8, 4 and 6. So they're pinned exactly the same. So why so you can do that? Can you really? So you know what I'm going to do? I'm going to stop for a minute. I'm going to look on the internet and let Mr. Internet educate me on this point, so I know for sure. Okay, so before I forget, after educating myself, so putting a 5U4 in place of a 5Y3 is probably doable in most radios. The 5U4 can supply more current than a 5Y3 without the plate overheating. So it's an oomphier, it's a beefier tube. But part of making it beefier is raising the temperature, I guess the temperature of the filament. Or in any case, it draws more current. So the 5U4 draws 50% more filament current. So now the rectifier is fed with its own winding. This is part of the trick of the power supply in these radios. It has its own winding. Here, it's a little bit more interesting to look at that. It has its own winding, and the winding has a capacity. This radio is designed for a 5Y3, so the capacity of that winding is 2 amps plus some headroom. The 5Y3 draws 2 amps. The 5U4 draws 3 amps. Probably the winding can supply the 3 amps. Probably the winding is hotter than it should be. It would have to be hotter than it could be. Is it getting too hot? That's the question. So if you're going to pop a 5U4 in place of a 5Y3, you got to ask the question, is that going to overheat the transformer? That's the main question. It may raise the B plus slightly. And I believe a 5Y4 is the same as a 5Y3 with different pinouts. But, you know, everything I say in these videos, please take with a grain of salt. I occasionally get things wrong. So, okay. So, because this radio came from a shop, the guy knew what he was doing. He put a 5U4 in there. This radio's been operated since then. The radio stopped operation when it was moved from one location to another, and it suffered all that damage that you saw. So conceivably, this radio is in perfect shape to operate, except for the 2 parts I found that disconnected themselves yesterday. So that's a resistor up here. Kind of pretty obvious where it's supposed to go. I think it's obvious where it should go. And the other one is this capacitor hanging on this long wire. It's a Hunt's capacitor. So I'm going to go ahead and replace this anyway, right away. It's another indication that the person who was doing this was using junk box parts. I'm not sure you could buy Hunt's capacitors over here. Probably you could, but I'm just looking for the size of it. 0.01. Why on the end of such a long wire? It's just the strangest thing. I mean, if this is some kind of weird workaround. Oh, I hope not. Isn't it, you know, resistor just sticking out hooked onto a long wire. These are abnormal connections. This is not the way the radio would have been built. So something different is going on here, but what exactly? I don't know. Okay, so let's hook up these parts, and I suppose it is possible, if you're smart enough, to figure out how to get around defective stages, things like that. I remember reading about during the war when radio repair became very difficult for lack of parts, because the war industries were using up all the material and labor. a lot of interesting ideas came out about how to get around things. The one that comes to mind is how to get around the defective IF transformer. And it's IF transformer, maybe it was output transformer, some kind of transformer anyway, and it's gone defective. You can't get another one. Just, the war is on. So you stick in a resistor and a capacitor in its place. So I mean, that gives you probably. I was going to replace that. What am I doing? Give you poor operation, but maybe it's only a matter of the radio not being as loud as it could be. And radios come with a repair switch on the front for those situations called the volume control. So if your radio has low volume, you have the opportunity to repair it with the volume control. You wouldn't even know it's broken. It's fantastic. I have a similar feature in my car. I have a fairly new car now, but years ago, when I was raising my family and there was no money, I had a lot of junker cars, and they all came with a repair feature. All of them with a built-in repair feature. So if you're driving down the road and your engine's just getting too noisy, you just turn up the radio. Perfect. So 0.01. So I think I'm just going to go ahead and do this, so you don't have to listen to me talk about nothing for the next couple of minutes. We'll get it done. What's exciting here is playing this thing. Okay, so I think watching soldering being done is exciting too. So we'll turn the camera back on here. Tricky to see where the wire is here. These hot resistors all around it here. What I believe are hot resistors. Oh, it would be interesting to look at this with the thermal viewer, and we'll see what's actually getting hot here. Let me just redo this. There we go. That's good. Okay, now what about this resistor up here? So it must have come right from here. You must have had it just barely tacked on. It just doesn't have the right shape. I didn't bend this at all though, so it must have come from here. Sounds like famous last words, eh? It's a fairly large terminal with a number of wires on it, so it's not too surprising. And maybe you had some trouble soldering it there. I have trouble with these. Great big guys here. Lots of metal to heat up, you know. Get a little solder in there, help the heat flow. I'm gonna have it tacked in also. That didn't work at all. It's just a moment of the soldering iron losing contact and the solder freezes. Oh! Ah! saw that coming. I'm a little shaky this morning. Now that's going to hold. It was just another tack. Didn't grab it at all. Okay, so this is not working out very well. So again, you know, this is a resistor that the last guy put in, assuming it's only been one guy before me on this. So we'll make that assumption. Blame it all on him. I'm really not trying to blame the guy. You know, he succeeded in making this thing work well and made his customers happy at the time. So, and you know, most people who get this kind of work done, including work done to their cars, have no idea what was actually done. They just hand over the hundreds of dollars and drive away happy because their car is good now, or their radio is good now. One of the reasons I make these videos, in fact, the reason I started making these videos, is so there would be no mystery to my clients when they got my bill. And well, I thought it would be fun to do this, but I really wasn't intent on making public videos for everybody to watch. In fact, the very first attempt at this was years ago, me doing a live thing, which I thought, okay, I'll just send a live stream of my shop, what I'm doing, and I'll tell my clients how to see the stream if they care to, and then they can check in on me. That was when I was doing a lot more of this work. Yeah, a lot more of it back then. And that just kind of led its way to, no, that's lousy too. That just kind of morphed into what I do now. So that's how come my videos are so little edited. The initial perspective on this was it was a live video. It wasn't even a video, it was just a live stream, not to be recorded. You know, when I did that, I then found out that the stream had been turned into a video and posted on my YouTube channel. Not only did I not know at that time what a YouTube channel really was, let me turn that around. Not only did I not know I had a YouTube channel, I didn't even know what it was. Really. I really didn't know anything about anything. And as for video technology, cameras, webcam, all that stuff, I didn't know any of it. But just like anybody and anything, you just plug away at it, and slowly the pieces come together. Now I have a really good video system. I think it's pretty good. And cameras and all my camera. I need new cameras. There's no doubt about that. Okay, so that's good. That's good. We're ready. Okay, I'm feeling pretty hopeful that this guy is going to work. So I think I'm going to rearrange the equipment, plug it in, and get it ready. Then I'll start up the video again, and maybe we'll be listening to this radio. I gotta find a speaker. Okay, so I've grabbed what looks to me to be a car speaker, I would guess, out of my box of speakers. Now we're going to test it first. I've got it hooked up to my signal generator here. So it works. It's not going to be very loud off of this. I just need a quick check. There we go. No problem. Just have to make a very good connection there. We're going to get that effect. Very good. So there's the speaker. Now the speaker is supposed to plug into here. So what I'm going to do, should only be 2 wires coming out of here. Let's see, I can flip this up, clip on the bottom. That's probably a better deal than trying to put something through here. Clip directly onto it. Now this guy, didn't I say I was going to do this off camera? Just make some space here. We certainly want this down in a more normal kind of position. I don't think we really... Well, you know what? We may want to look under here quickly. Yes, I think we'll leave it up. We'll leave it up like this. Magic Eye doesn't need to be plugged in. It has no bearing on the actual operation of the radio. Let's swing this around. I got to check right away and make sure I can get one of these. What if we can't? Oh, what a disaster that would be. So I got to find that out right away. These are... Wasn't there a floppy light? Yes, there's a floppy light here. Can we unfloppy it? Where is it supposed to go? Don't know exactly. So I'm going to put it somewhere, just so it's not floppy. Stick it here. Oh, what just happened? This whole piece just moved like a 1/4 inch. Don't tell me it's not bolted together. Don't tell me that. Oh, it must be. So this is just probably grommet play here. How am I going to check that? Yeah, it's just play in the grommet. Play in the grommet. Everything else is okay. Yeah. My power goes in. This guy's got a plug across here. With cords like this, by the way, I do my best to avoid rebending this part. I try to leave it in the same way it's bent. It's bent this way because that's how it needs to be bent, supposedly, to be plugged into here, and that's the way it's going to hang and all that stuff. I try to leave it that way because later this can become a hint on how to put things together. I don't think it will in this case, but so this is the power cord. No, this is the sub power cord. So we'll put it in here. Start the whole thing up at once. Is that a smart idea? Because the owner has told me the set works. Oh, here's another thing we need to look at before I fire it up. 3-prong plug. That's great. What did he do with the green wire? So he's locked the green wire to the chassis. We have a white wire. See, this could be. Since this was probably originally a non-polarized 2-prong plug system, there's probably no problem with anything here. Having the green wire on the chassis, no problem. This plug only goes in the outlet one way now. I'm plugging it first into a isolation transformer. Now, the 3rd prong here, just so you understand what's happening, plug this in. There's the 3rd prong. It's not plugged into anything. So the 3rd prong is not connected to earth ground or power system neutral or anything. And the power coming here is coming from a transformer in order to isolate this piece of equipment from all the rest of the electronics in here for safety reasons. Now, there is no situation in a shop like this, in my opinion, that is perfectly safe if you just set everything up a certain way. They always come with a caveat. And if you know what you've done, you can keep yourself safe. And that's kind of the situation. So for a while I had a shop, no isolation joint. I had an isolation transformer. I had other systems to try to keep me safe, especially with the 5-tube radios. Today I have an isolation transformer. It still doesn't guarantee I can't get a shock. That's why I'm a little bit hesitant here. If you watched enough of my videos, you will have seen me get 3 or 4 shocks over the last few years, all of them minor. But any one of them could have been bigger than minor. Okay, so I got to get this connected here. So because any one of those shocks could have been bigger than minor, there's just two wires. Maybe I can get into the pins here. A pin here and a pin here. Just the 2 wires, as I suspected. That's a big one. That's a smaller one. Yeah, I'm gonna have to clip. I'm pretty sure that's the only way to do this. And then I gotta get clip leads out from under here. I don't want these clips doing anything bad. They're gonna be out of sight. Clip leads. Gotta love them, gotta hate them. That's not working. So I have clip leads where every time you squeeze them they rotate, and because of this plastic it's so slippery. That's good. Okay, a short circuit here. That's not the best thing, but we'll know it right away. Okay, there's the fuse, and he's put some paper here, I guess. Again, he's only fused the fused part of the system here. There we are. Speaker. Now we'll make the connections here, but we know there's a chance they won't make properly. So there's a steel plate or plate coming right out here underneath these. So at a glance you don't see it. I guess that's probably a stiffener or something to stiffen this whole thing up. Wow, if I just clip like this, that's what it must have been doing to my seal generator. I'm clipping onto a piece of steel in the back there. Son of a gun. Okay, let's go right on the voice call wires. I don't really care about this speaker. Right on the voice call wires. There we are. Okay, man, where can we put this? We'll put it over here. We don't need it anywhere near. Bye. I think that's it. Okay, now what I got to do is I got to teach myself the volume control here and not get confused with the tone control. So there's something going on over here. This has the on-off switch on it. And this one also has this is just a switch. Just a switch. Whew. We'll look at the front of the radio in a moment. Maybe it'll tell us everything. This is probably the volume up here. This is the tuning. Probably the volume. What an inconvenient place to put it though, way up here. Of course, this is in a big floor standing radio. And it does have a wrist position. I'll show you it in a sec. What I mean by that. It's got, this must be the band changer. See the whole mechanism moving back in there. Ooh, that didn't sound very good, did it? Oh, crunchy sounds. I don't like that. Okay, so let's look at the front of the radio here. I'm not sure if my camera will make it all the way over there. Let's see what we can do here. Around we go. There's the radio. Okay, that's about as close as I can get here to it. There's nothing on here. This is the wrist. This is what I would call the wrist place. It's not very good. When you're tuning a shortwave radio, it takes a little bit of time to tune it. You gotta spend time with your hands out, and you need a hand on the volume control while you do it. What is this? What is that? Let me see if I get the camera a little bit closer here. Or use a different camera. I'm going to take a look at what that is. Well, this turned out to be a tough shot to get. So you can see I've mounted the camera right onto the front of the radio there. It's staring right into that little window, and this is what we see. What is it? What is it? I'm going to just... Not coming clear to me. Brilliance. I think that says brilliance, I think. Brilliance. Brilliance. All say the same thing. No. 2760. What the heck is this? So this could be a radio station, WGN 720. Oh, look at that. There it is. There the answers come. KMOX 1090. So this is the tuning dial for AM? I thought the tuning dial was not here. What's going on inside the radio? Look at this. Well, this wheel appears to be connected to absolutely nothing. What is going on here? Let's go around the back and take a look. There it is from behind. Ship is a little bit bad here. That's the wheel. Again. There it is. Just sitting there. Why? Maybe this is a memory wheel. Maybe this is in the radio literally as a guide. It's a built-in guide. You turn the dial and it reminds you. WGN is 720. Really? I guess that's what it is. You know, when you look at the radio, the real radio, look at the chassis. What do we got that's down in that area? That dial. The center of the dial we were just investigating is here. But took the chassis out, if you noticed, maybe you didn't notice, the knob stayed behind for that wheel. Because the wheel's not hooked up to anything. That's what it must be. It must just be a guide, a built-in station guide. Okay, now I think we're ready to turn it on. Is there any other big question marks here about this guy that I should be really concerned about? I don't think so. So another thing about powering up something like this, I use a what some might think is a low-tech approach, but I actually really like it. I use the dim bulb system to block or restrict's a better word, current flow into whatever it is I'm testing. So these two light bulbs here, which I'm going to undo one of them, the electricity reaching the radio from the power line goes through those light bulbs first. That consumes some of the electricity or reduces the power, however you want to look at it. So ultimately, instead of running this thing at full 120 volts plugged right into Niagara Falls, instead it's going through some restriction, so maybe it's going to get 80 volts. A big guy like this, probably going to start off with 60 volts or 50 volts. That gives me a little bit of time to see if there's anything bad happening. Don't expect there's anything bad happening. And you know, before we turn this on, I've got to get my thermal viewer ready, because we're going to want to start looking for hot stuff right away. So I got to get a battery for that, and I have to go say good morning to my wife too, and we'll be back. Okay, so here's my thermal viewer here. Just a quick explanation on how this works. Of course, it's going to show an image based on the temperature of things in the radio. So what do you see right now? You don't see much of anything on here because nothing's hot. Okay, but let's just check the sensitivity of this. Put my finger here. Well, my finger's not terribly warm. There's my finger. And when I take it away, you cannot see the heat imprint. But anyway, because you can see my finger, you certainly get an idea. So I make adjustments on this to make this a little more suitable for what we're doing. First thing I'm going to adjust here, the top temperature. This is the color scale here. The thing always reads what it always reads, but the screen can be altered in how it presents it to you. So the top temperature is 35, so that means things at 35 degrees, 35 degrees will show up in red. Well, I want it much higher than that. I want it higher. Oops, that's the wrong way. It's 30, 30, 40, 45, 50. So now a 50 degree thing will be red. Probably a 40 degree thing will be a little red too. And the bottom temperature is 20. That's just below the ambient in here. The ambient's probably 22 or so. Well, you can see it right here. Can you read that? Cannot read that. 23, 22 degrees in here. Okay, I think we're ready. Right, so I still don't know for sure what the volume controls are. Probably this one up here. This, I don't know what this is. Probably some tone thing. It's hooked up to the volume control. So maybe this is all tone here. I don't know. And that will leave this one to be volume over here. Okay, so maybe that makes sense. So the set is switched. Oh, the whole control is loose here. Isn't there a switch on that? I thought I clicked it last time. Okay, so don't worry about the switch. It's in the on position. Volume down. Ready to go. So what'll happen here is this little light over here is going to come on quite bright and probably just stay that way. That's probably what's going to happen. And away we go here. Wow, take that back. Okay, so everybody freeze. Nobody move. 122 volts on the plug. Why is the set not come on? Why did the set not come on? This is on off? Can't imagine it. This has got the power wires coming from the transformer. This is on off. Why aren't you on? Why are you not on? So busted switch? I couldn't mechanically turn the switch. Maybe the switch broke. Maybe the switch broke. Here, this is what I'm looking for. Now, don't forget, some power is on here. Actually, 120 volts is on the wire coming into this thing now. It would be much lower if it was drawing current. Let's see what the voltage is right across the switch. It should be 0, but if it was 0, I think the radio would be working. So 120 volts here. Mother-in-law call. Okay, so just helping my mother-in-law with her broken computer. She had a hard drive failure on her laptop. I went and saw it yesterday. And I had to break the bad news to her. Need a new computer. And I broke the good news to her because she doesn't, you know, she's 88 years old. It's great, she lives on her own, can work a computer, all this kind of stuff, has a great time doing it. But of course her depth of knowledge isn't all that deep. So I was happy to tell her that most of her documents, in fact all of them, are all saved on the internet. So she won't lose anything when she gets a new computer. Okay, what was I doing? That's right, I was about to check for the 120 volts across the switch. Right, here we go. So this should say 0, but I think it's going to say 120. 120. Son of a gun, I'm sure I operated that switch. Okay, let's cut the power here. What happened to you, Mr. Switch? Kind of surprising, but broken on-off switches are really common in radios. Well, I'm sure it clicked before. Well, isn't that disappointing? Okay, and so, you know, volume controls like this with a switch on the back, not the easiest thing to replace. It's a has three terminals, so it's not the most complicated. Like, it doesn't have a fourth tap off terminal. But for now, what I can do is I can put a short on there. A short that's going to carry a bit of current. So I think I'm going to actually short it with a piece of wire wrapped around it. And for the sake of my own safety, I'm going to unplug it here. That guarantees things. Now I need a little bit of wire, a little bit of wire. You know, that's the hardest thing for me to find. Oh, here we are. Ah, some braided, twisted wire. Definitely unplugged. I'm going right at the power line here. Now, I could have faked getting a shock right there, but I think that would be too upsetting to you if I did that. So I don't like to do that. I don't joke around with shocks. Like I said before, most shocks you get in a shop like this are actually fairly minor, current limited shocks. Not necessarily, but most of the time. Now that's because you're defending yourself. I would say this. You're defending yourself against the big bad 120 volt shock like I'm doing now. You know, by unplugging this and stuff like that. I'm not so good at defending myself from lower voltage shocks or shocks of other sorts. That's why I got them. Okay, and wrapping wires around a switch terminal is not exactly a very decent way of doing this. Let me pinch it tight a little bit. I don't know. Okay, so if this is probably where we'll find the heat, right, right in this connection. I think that's going to be good enough. I don't really want to solder it. Make sure nothing else is shorting here or touching anything. She's good. Okay, ready again. Getting more exciting every time. Let's back up, everybody. Get back. Stand back. Power. Plug in. So this time, doesn't matter where this switch is, she's going to come on. I've got it turned down. That means this little light's going to come on really bright. Probably nothing else will happen. Speakers connected? Yes. Let's get this out of here. Okay, and, it's not that common I have explosions in my shop here, but here we go. As predicted, that light is on fully bright. The power reaching here now is so low it's not enough to operate this little guy here. But I have some other meters, which I never show people. I had this one. Can you even see it? This guy here. So this meter actually reads percentage. 100% means full line voltage. It's reading 10%. So it is a trickle of power reaching this. Now, if there's a short circuit in here, a serious short circuit, that light will look just like it looks, fully bright. So this could be telling me there's a dead short. This could be telling me maybe I'm stupid doing that. I don't think so. I'm just rethinking whether I'm stupid or not. Okay, what I'll do now is I'll screw in the other light bulb. This will increase the current flow coming to the radio. It'll increase the voltage supplied to it. And if I screw in the light, okay, and I'll watch the other light. If I screw in the light and the other light doesn't dim down, then I know there's a short. There we are. That's the way. Here we go. Dimming. It dimmed for sure. Okay, now we've got only 40 volts. Slowly coming up because the heaters are heating up in the tubes and everything, and increasing their resistance, lowering their draw. They lower their draw, less current being drawn by the radio, less voltage drop on those lights, more voltage left for this guy. It's only 50 volts. 50 volts. We can't expect too much here at 50 volts, I don't think. We certainly can't expect it to operate. That would be a fat chancer. But let's see if anything's getting hot yet, which is also a bit of a long shot. Be pretty stunned. How about that connection I made? No, that's just fine. Be stunned if something shows up. And maybe if you leave it running long enough, we might see something. I can make this a little more sensitive too. Sensitive in the sense that what turns red is. So let's see a little more now. You can see one resistor there. That's this one here. So that's a guy we want to keep an eye on, because if he's warmed up already, he's only going to get warmer. Here's another one. It's already warming up. Now, its temperature is 26. You probably can't see this on the screen, but I can see a little red plus line jumping around on here. It's jumping to the highest temperature pixel and reporting its temperature here. So I can actually read the maximum temperature that this thing is seeing. 27. And over here, 28. So that's nothing in terms of radio operation. There's nothing going on here. That's something else down here. So that's a tube base. Can you see that? Yeah, you can kind of see it. So that's a tube base, I'm pretty sure. There's no components down there. Okay, so we're ready to take this up another notch, I think. What do we have? 50 volts, still very low. So what's happened is I've got fairly small light bulbs in here. So I'm going to, because this is such a big radio, I'm going to have to use my big bulbs. So this is a 100 watt bulb. I'm going to swap out the little 25 watt for this big one. Okay. And I'm going to shut the power off while I do this. I'm going to, is it hot, hot? A little hot, a little hot. Ooh, a little hot. So this will be, I think this is a 40 or a 60 here. This will not be that much restriction. At least with a regular radio with, 6 or 7 tubes in it, this would not be much restriction. For this guy, because he's got a dozen tubes in it, this might still be quite a probably better off like this. Ready again? Lights in. $72. give it a little bit of time. You see the 3 light bulbs are lit. That's pretty good, 3 working lights. Okay, who's getting hot? So still some heat down there. Remember, I've made the screen quite sensitive now, so it doesn't take much to show up. So you see that resistor there is warming up. The one it's connected to, yeah, something red there. What's that? Oh, for crying out loud, it's not even in the... Oh, you know what it is? It's the light bulb. So remember, I made the screen very sensitive on this. It won't take much. In fact, I'm going to desensitize it now. So we'll raise the red to 50. 50. So come down here. Come over here. 31. I saw something pretty hot up this way. So I've only had this device for a short while, and this is one of the first times I've really got a chance to try it out. So that guy is running at 30. That's still not very hot. It's really not very hot. So we would need something blazingly red here to really get excited over, I think. So, what do you think? Full power? Give it full power. We're only at 66 volts, so we're nowhere near full power yet. I got another light bulb. What have I got here? A 60. Boy, it's a big jump to full power from here. Okay. This is probably too hot to touch. Not really. What am I going to do when there's no more incandescent lights? That's a 60 already. It's already a 60. So that's it. This is the most restriction I can apply. There is one more thing I can do. You know what I can do? I can pull this plug out, shut off the big amp. Why not? Who needs the big amp going when I'm doing this? That big amp, oh my gosh. The big amp is probably pulling a pretty good chunk of power itself. The big amplifier over there. Okay, so the amp's out. This will mean this will draw less current. Those bulbs won't be as bright. This voltage will be higher, and the set may start working if we can get up around 100 volts or so. There we go. 93. Well, we're getting up around 90 volts now. Still too low, I think, for the set to actually operate. Of course, I've done away with the amplifier, so we're not going to hear anything. Those are the light bulbs that you're seeing there. Actually, you know, you get a better view of this than I do, because you're looking more straight on, and I'm looking on an angle. I'm going to watch what you're seeing in the screen here. Aha. Right. That guy. Same guys. They're not getting crazy hot. That's getting up around 40. So, and we're at about 90 volt supply. So there's nothing here that's screaming out at me. What is that? That's my TV screen, I think. Oh, you can't even see it. Okay, so I'm reassured. Nothing really terrible is happening. So what I'll do, what will I do? At 90 volts, the set may be working. If I plug the power, if I plug the amplifier back in, it's going to draw enough current to bring down the voltage even lower. We're going full power. We're going to go full power first with just this. Are you ready? Let's get our thermal thing ready here. Well, I'm not too concerned now. Full power. Listening? Don't hear anything scary at all. We'll take a look. See where we're getting to now. So this guy has come up to 75. that's getting a little hot. 75 is a little too hot. This guy is up around 50. Even 50 is a little warm in the back of one of these radios. And this guy is running around 45 or so. And that's really all it amounts to in here. There's nothing else that's crazy hot. Just this, you know, the resistors that are hot. This one with the burn paint, this one with the burn paint, and this one with the burn paint. This one with the burned off paint is completely burned off. Is not hot. $10 says this was a problem the guy solved with capacitor replacements in this area. Did I say 10 bucks? I didn't really say who I'm betting against. So we're starting to see the tube bases show a bit of heat. Yeah, that's definitely a problem. That guy there, he's 110, 112 degrees in this thing. And the one it's in series with, look, it's just a little bit warm. I can measure its temperature. There's a plus in the center of the screen. If I just tip this until the plus is, well, this big number here is whatever the plus is on. Let me get it on this one here. Okay, this is the other resistors, 40, 50. So that's a problem. That can be improved. Let's put it that way. I shouldn't really call it a problem. I'm not hearing anything. Oh, amp's not in. I didn't plug the amp in. Right, I didn't want to plug the amp in because I wanted to run this full on its own. Let's power off. We plug in the amp. And what are we going to get now? So now we may hear something out of the speaker over here. Just sitting over here. Don't really know what band we're on. Not sure about the volume control, but they're turned down anyway. So I think we're ready. Ready. We can start this up again on dim lights. Now this tube has a rattle in it. Oh, it stopped already. So sometimes the tube elements, you know, as they heat up, they expand, and mechanically their situation changes a bit. So at first everything's shrunk, maybe a little loose. You turn the tube on, and there's vibrations in there, you know, from 60 cycles or whatever. And as the things heat up, they kind of jam into place. Sound gone. That's what I think. 66 volts. I won't even try hearing something. Oh, you know what? I can hear something. Can you hear it? It's a hum. I have another microphone here. I can swing over the speaker, and then I'll let you hear the hum. Bit of a shop improvement here. I've included a microphone boom. More flexibility with microphones and stuff like that. Okay, let me put on my headphones, see if I can hear this too. I'm going to shut off all the microphones in the shop except for the one you see. Oh yeah. Oh yeah. That's a hum. That's a bad hum. That's a hum at 66 volts. What's it from? Okay, so we have a couple options here to figure out what that hum is. It's almost certainly the power supply in the amplifier, but I don't know that. Right now I'm feeding a sound signal. What all's on this wire? This wire here. I'm tempted to just pop this plug out. That's not a good idea. It's got these hot resistors right on this plug. What is this conveying over here that I don't quite get this. So it looks like, the B plus is filtered right in here, and it looks like the B plus is being sent out on this wire. But at the same time, it's got its own power cord and what looks like clearly a rectifier and a power transformer. What's up here? That's not making too much sense to me. Well, aside from pulling out what I think is the input to the amp, left channel, right channel, but wow, how else can this amp get a sound signal? There's only two possibilities, the power cord, no, or this. Well, this is hooked up right to the B plus here. It looks like it's hooked up to the B plus. Maybe that's a ground terminal. It's got a black wire coming off it. Thank you for being black. It just goes way up into here somewhere. Not at all sure what's going on there. You would think they might transmit the sound on a shielded cable. I mean, this is a lamp cord somebody has braided together. Yeah, this could cause a hum. Let's try running the amp all by its lonesome. See if the hum remains. So I'm gonna pull this out of here. And I'll plug this right in here. We'll start with restricted power again. The humming microphone is off. I'm just going to bring that up along with all the other mics. So I got all 4 mics going in here now. Just so you know what I'm up to here, because you might be curious how I do things. So up above my bench here is a stereo microphone left and right. And this is normally what you're listening to me speak through. When I turn to my computer, which is this way, I have a microphone hanging right there, which if I remember, I can turn on. Sometimes I don't turn it on. Most of the time I leave it on all the time. And then I have this sort of utility microphone over here, which I seldom use, but will probably use a lot more because I got it on this nice stand here. That's the story on the microphones. All of them are on. Plug that guy in. Turn them on restricted. Not much restriction now. You could hear that tube rattle briefly. So the hum come in. Static, I don't know what the static is. I'm not sure why there should be any static there. I didn't notice it last time. Something else we really should do with this is look at it with a thermal viewer. Like, I'm going to power it off. This is on restricted power. This is only running, it's 95 volts. So that hum would be a lot stronger if I hit it with full power. I'm just going to turn it off here. I'm going to tip this guy up. So the challenges are starting to show up. That's what I would say here as we do this. They're coming home to roost. Oh yeah, there's that weird resistor in here. Okay, power back on. Just restricted power. That's the hum. Let's get our thermal thing here. So right away, that resistor down here is showing temperature. What is it? 70 degrees, and this is with restricted power. For sure, if I turn this power on full, you'll know why that resistor looks the way it looks. It looks like it's just cooked away. There's almost nothing else in here to get hot. There's just nothing else in here. It's just that, a little bit delay in the screen and I swing it. Yeah, there's no other parts. See, the resistor terminal is floating here. It's been soldered in some weird way. You know, this is another example of the last guy who worked on this doing something. Now, he may have just replaced an existing resistor, but you wouldn't expect it to be floating out here like this. So what's going on? I don't know. It looks like he's changed the capacitors. Maybe he had to do something to accommodate those capacitors. I can't imagine what that would be. And this resistor really appears to be between the two capacitors. So this is definitely, it's not, you know, in a better amplifier, this resistor would be a choke coil. Why isn't it a choke coil? Isn't there another coil on here? This looks like a choke coil. Okay, so lots of questions. Lots of questions. Obviously, a lot of the answers are going to lie in studying the schematic, so I think that's where we're going next. I think I'm going to find the schematic, and I'm going to go through the whole thing and get familiar with it before I start fiddling around with this guy, but generally, it's not terrible. Well, the hum is kind of terrible, isn't it? Talking about that, we don't have to listen to it. So, thank you very much for watching this video. The work is starting to come clearer. I don't think there's anything really serious here. There's a lot of little part work that's got to be done, I think. Great. Okay, see you on the next video. And I'm going out to enjoy another day of fantastic weather. It just never ends. It's just been the greatest summer here. Hot sun, cool air. Wow, you can't beat it. Sorry about what's happening in Florida. Wish you had our weather. See you on the next video.